All right. Hello, everybody. I hope you all have had a wonderful time so far. And I hope you can hear me. To kick things off, I'm going to be introducing Melissa here. So Melissa has worked in nearly every software development role, dev, test, DevOps, and program management at companies big and small and somewhere in between. She's created and run high availability, high quality services for PlayFab, Bing, Cortana, and Xbox One, and now for mParticle's enormous data platform. Melissa discovered her love of massively scaled systems while growing the Bing backend, where she honed the art of keeping highly available, complex systems up while undergoing significant code churn. Now a director of engineering with mParticle, she's passionate not only about maximizing efficiency both in her product code and in her developer tools, but also about sharing the best practices among colleagues and the tech world at large. Now, a little bit about Melissa's presentation on fuzz testing for fun and profit. A software test is no better than the data that drives it. Fuzz testing is a great way to find buggy, exploitable, or otherwise bad code. And if you're working with a native application that operates on file input, it's a solved problem. Grab AFL or some other all-in-one suite, hit go, and profit. But what about web services? What about managed applications? For a service-based developer, fuzz testing your HTTP serving layer isn't all that interesting if you're running on the latest version of Apache. Fuzz testing your application along its interface boundaries, though, very interesting, and not a problem that can be solved with an all-in-one suite off the shelf. In this technical talk, Melissa will demonstrate not just about what fuzz is testing, but how to use it to test a service architecture at every level and interface as a key part of any continuous delivery strategy. Using real-life examples and experience, she will demonstrate how easy it can be to integrate both mutation, generation fuzzing into an existing test strategy for services that operate at any scale, from micro to global. Every services developer should be able to feel confident not only that they've sanitized their inputs, but that they've been validated. All right, Melissa, you ready to go?
I am ready.
Awesome. All right, the stage is all yours.
Great. Thanks, Aiden. So hi, everybody. My name is Melissa Benua, and we're here to talk today about a little bit of fuzzing. Fuzzing is fun. A word of warning ahead of time. It's a very windstormy day, so hopefully we don't run into any issues or flickers, but bear with me, should be fine. You may or may not also see some background cast of characters coming behind me. Please pretend they're not there. I try my best to, but they are very cute. So anyway, we're here to talk about fuzz testing. And if I look like I'm doing something weird, I have a clicker in my hand because it makes me feel like I can pretend that we're all in person together, even though we all know there's Zoom going on. So who am I? So I am currently a director of engineering with a startup called mParticle. I run a number of teams, ranging from backend engineers to test automation / dev test SecOps. Before I was doing that, I was doing those things directly myself as an IC. And so I've got a lot of experience doing coding and engineering in general, where various boundaries intersect. So being a developer, but also with a strong test background, doing test work, but with a strong security background. You get the feeling. So what I'm going to talk to you today is about testing, but it's also about security, and it's also about writing efficient code. And it's something that I first became really passionate about when I was working as an SDET. So I started my career at a very, very large West Coast company that had SDETs back in the day on a very, very large web service that I'm sure many of you will figure out before the end of the talk exactly what I'm talking about. But so years ago, I was working on the service. I was an SDET, and one of the very first things that was handed to me when I joined the team was this thing called the forking service. I'm going to be very careful when I say the name, the forking service, because we often called it other names that I'm sure you can extrapolate about, especially when it did things like break people's test environments. And so what the forking service was, it's sometimes otherwise known as teed traffic. But basically, it was something that took real production data, sanitized it a little bit, right? Anonymized some of the identifiers, et cetera, and then made it available for replay at a certain percentage into any of our test environments. So you could run a production-like set of traffic against your parallel prod environment, for example, or you had a debugging enabled, or against your release candidates, or against a highly tuned performance environment, so you could look for, performance issues. But anyway, so it would take a small percentage of real traffic. It would send it, to our test beds, and everything was great. It was used to validate any release candidate. Like, you had to use it to validate a release candidate. Any build had to sit for 24 to 48 hours without any major crashes or memory leaks or weird things. And then at that point, it could be considered stable enough for production. It was a pretty important service. Everybody relied on it. Everybody knew what it was, more or less. It was pretty stable. But so it wasn't perfect, and we would still miss issues. And so as a young and aggressive SDET, I said, great, I own this service, and everybody knows that this large West Coast company, the best way to get promoted is to own and or make major updates to a testing service. So I said, how can we make this better? How can we drive out a whole new class of issues that basically are being untouched or very lightly covered right now? And so I went to a couple of internal security talks where they were talking about, in particular, this fuzzing library, this native code fuzzing library that they had published internally for people to use. Had a bunch of attacks. It was pretty cool. And I was like, oh, this is interesting. And I proposed to my manager, I want to see if I can integrate some security testing into the forking service with maybe a little fuzzing. And he said, sure, I guess, whatever. I didn't really know what I was talking about, but he gave me a couple weeks and said, go to town. So I took this library and I took the forking services, existing model of what our traffic looked like, because it had to have some basic model in order to do any sanitization. So I combined this library with our model, and I created this thing called the fuzzing service. And it was really just a layer that sat on top of the forking service. But it just made the traffic a little more interesting. So if you had, if you're leaving an HTTP request and you had something to, foo.com//search, in the query param line, you had foo equals bar. It would take your bar out and insert an alert box, alert, I got you. And so I did this thing, I got it ready to go, it got PR'd by my peers, and finally we hit the day where we were ready to turn it on. And nobody had been paying that much attention to what I was doing, but we did have a big release coming up in the next couple of days. And so I sent an email out to my team and I said, hey guys, just so you know, pushing out an update to the forking service. You might see some changes in your traffic. I don't think anything terrible will happen. Famous last words. Don't think anything terrible will happen, but it'll probably be fine. Let me know if you run into any issues and I can make a change. And I sent the email. I hit push, right? I hit the deploy button on my on the new version of the forking service, and then I got up, walked away from my desk, and went to get a coffee. And as I was walking back to my desk from getting a coffee, I could hear variations of people talking about that forking service. The beds are forked. Somebody help! The beds are forked. We can't validate anything. What is going on? I'm trying to test my code. Fork me, it's not working. You get the idea. So I hear all these people, and by the time I sat down and unlocked my computer, I had like 5 or 6 IMs from people saying, hey, whatever you did, stop, turn it off. You're blocking validation for the release. You need to stop immediately so we can validate and send stuff out. And I said, maybe I must have, sent too much traffic or whatever. So I turned it off. And as we start investigating what's happened here, bad things have happened, but not bad things because I did bad things because it turned out that our stable code that had been sitting under, the release candidate had been sitting for a couple days by now in the release candidate environment, getting ready to go out, had immediately cratered to the ground with a bunch of different crashing issues. And every time it tried to come back up, it immediately hit a crashing query again, cratered to the ground. And so everybody went really quiet. And all the devs went off and scrambled to fix the bugs. They fixed 3 or 4 crashing bugs that day, pushed it up live. And then they came to me and said, hey, whatever you did the other day, can you turn that back on again, please? And so I did. I turned it on, and then I hear more fork as the beds go down again. And then, whoops, there were 4 more crashing issues. So they go back, I turn the traffic off again, and then they frantically fix 4 more traffic issues. And then we repeat the cycle a couple of times until finally, at least the bed will stabilize and I can leave the forked traffic up. There were more issues. Once we got through the P0, oh my gosh, crashing issues, there were other interesting issues, and we'll talk about how we found those later. But there was a lot of scrambling and fixing on code that had been quote unquote stable and ready for release. And the really interesting part was not all of the bugs were in net new code. A bunch of them were in code that had been in production for 3 months, 6 months, in some cases a couple of years. There had been, every now and then we would see these stack traces, but you see it once every 4 months, and so it was never a priority, right? One crash every 4 months. That's not hard. That's hard to reproduce. Whatever, people don't care. But all of a sudden, when we could reproduce it quickly and easily, they cared a lot, fixed it immediately. And we had so many interesting bugs. They were from issues in the C++ web service to JavaScript vulnerabilities rendering. We had crashes and memory leaks and deadlocks. We found all these issues just by making our traffic look super, super, super weird. We had things that were easy to find. You just pulled up the stack, you pulled up the core dump combined with the traffic log. We had things that were really hard to find, one including a cross-process memory contamination that luckily never went out into production. Right? That's horrifying. If you can leak somebody else's personal data with a specific set of queries. Thank goodness that never made it live. So how did we do this? This is what we're going to talk about today. First, I want to lay down some pretty basic definitions, because software as an industry has definition problems. When I say something like, we're going to do integration testing, it probably doesn't mean in your head the same thing that it means in mine. So I want to lay down some very basic definitions here. Starting with, yeah, you're going to see the dog keep going back and forth. Starting with fuzz testing. So fuzz testing, if we use a more academic definition, is just generating random input to explore the bounds of our system under test. Pretty simple. And so when I talk about an attack, I'm going to talk about the specific data in that input meant to drive out a specific class of bug. For example, a SQL injection attack. And then we're going to talk about manipulations, which are the combination of your input combined with an attack. And of the 3 manipulation types we're going to talk about today, the simplest one is a creation manipulation, which basically means substituting in a de novo, brand new generated input from an attack. So imagine replacing your entire query string with an alert box. That would be a creation manipulation. Whereas an assertion manipulation is modifying a known input to include an attack. So imagine if you had a search thing and you said, Q equals ponies, it would then be, Q equals PO semicolon alert box. NIES. And finally, we have a genetic manipulation, which we're not going to talk about too much today, but which the really cool fuzzers, especially the local ones, do. And that's successively modifying your input based on system behavior. It generally requires white box fuzzing, which means you need code coverage or some way for the program to see what branches it has explored and what branches it hasn't, in order for it to intelligently continue trying to fork its way all the way down to the end of your to every branch in your logic tree. So these are the definitions we're going to use today. And here's the keys of how to do this in a good and efficient way, right? Because it's great to have a good set of attack sets. It's fantastic. And it's really good to know your model, right? The more you know about your model, the more intelligently you can apply those attack sets. But the important keyword there is intelligently, because in order to be really efficient with your time and resources, you need a plan of how you're going to apply those attack sets to your model, because not everything is important to fuzz. Especially if you're in something like a CI/CD world where you don't have 3 or 4 days of stabilization on a 6-month release or whatever. You want that code to go out immediately. You want it to go out as fast as possible. So we want to find the balance in between, yeah, if we ran for 5 days, we would eventually explore, we'd cover 99% of cases. Get something closer to if we ran for 15 minutes, we'll explore, 97% of cases, and that's good enough. Because, there's going to be things you care about and things you don't, right? Your model in particular here is the things that you actually care about, right? You probably, if you're running a web service, you probably don't care about what's happening at the TCP layer because your web server does that for you. Right? You don't necessarily care about fuzzing your web server. I'm not saying nobody should fuzz a web server because somebody is fuzzing a web server, but probably that should be the people who publish the web server. What you care about is your application. More specifically, right, if you're only responsible for a part of the application, you really just want to validate the part of the application for which you're responsible for. There's not a lot of value in testing your, your auth system if what you're assigned to do is testing your commerce part of your website. A little bit of, incidental testing of the auth system is fine, but what you really want to be hammering on is the shopping pages and the cart pages and the checkout pages. You want to be able to do the things that are important to you, right? Because that's what we get paid for. We get paid to do our jobs. So let's talk about what data models are. So here's where we start. We're going to start with the model. And if we're talking about web services in particular, we are probably very interested at the HTTP level. And so this is where, this is the foundation. This is a raw HTTP request. It's a GET request. It goes to some totally random website. But what we want to do here is it's not just random strings here. This actually has a model, right? An HTTP request has a format that it needs to look like. Otherwise, it's going to get thrown out by your web server, and it's not going to get very interesting. I'm not particularly, I'm interested in what Apache is doing, but I'm extra interested in what my application is doing on top of that. So, right, I need to know that this web service has a model. It has to have a URI. The URI has a specific format. URI has a query parameters. The query parameters have a different format layered on top of that. That format is separate from headers, which always have to look a certain way or they'll be rejected. Even within headers, right, the cookie header has a specific format on top of that. Right, the cookie format is ampersands and equal signs separated by semicolons, which is different necessarily than like an accept header. And so knowing the data model of all of these things is what's going to let you be really, really effective. Right, if we look at JSON, it's the same deal. JSON-based, if you have a JSON-based HTTP service, what you care about is probably most of what's happening in your post body. Maybe your application doesn't use query parameters at all. If your application is never reading off the query parameters and you configure your fuzzing run to spend 30% of the time fuzzing the query parameters, that time is wasted time. Not because nobody should ever test a query parameter ever, but because that's not really relevant to you. So again, right, if we're looking at a JSON-based HTTP request, parts of the model still apply, right? Obviously, HTTP requests are still requests. They still have methods and URIs and versions and headers. But what you may care about would be the JSON post body, which has a specific format both at the HTTP request level, and then JSON itself has a format, right? You have to have your braces and your quotes and everything in the right place. JSON has the concept of objects, right? So if you have arrays, they should be valid arrays. And so the more you can respect your model, the deeper you're going to get in your fuzzing attempt, right? If you never ever send a valid JSON array because your fuzzer doesn't understand anything about it, then you're never going to do anything interesting like fuzzing, say, a timestamp within there. Fuzzing, if you can't figure out what a JSON object looks like, you may not be able to intelligently fuzz a customer ID or other things that may be surfaced in an interesting place in your application. So let's jump ahead to attacks. And this is not an exhaustive list. This is not meant to be exhaustive, but I sort of want to give a high level overview. So attacks can be anything from very, very simple to extremely complex, custom handcrafted exploits. I personally get a lot of distance out of A's, out of random strings. You'd be surprised at how far you can go with, with a couple of A's. And I don't mean like 3 or 4 A's or 10 A's are on the slide, but I mean 1024 A's, 1023 A's, 4096 A's. What happens if you append a kilobyte of A's, 5 kilobytes of A's into your query line? That's interesting. You don't know how many times I've found memory leaks in places that things weren't being exposed by stuffing so many A's in there that it's really hard to miss when the A's inevitably show up in other places. But of course, you've got your SQL injection. You've got control characters, which I'm always amazed that PowerPoint doesn't crash every time I show these, because it took probably 20 minutes just to get the control characters and some Arabic pasted in. You can find XSS vulnerabilities. You can do integer overflow. You can do redirects, et cetera, et cetera. I'm sure you get the point. Something to keep in mind, though, is if you are looking to invent all of your attacks by hand from scratch, please stop. This is not probably the best use of your time. And I'm not saying you should never custom craft any of your attacks, but I am saying that there are a lot of them that are already published and collected. I personally like looking at FuzzDB, though I know it's getting a little aged. But you can collect existing exploits that have been used to exploits that have used to take advantage of real vulnerabilities and just maintain that in your list instead. And that will be a lot simpler for you than trying to invent everything all on your own. There's no need. It's a solved problem. So if we consider that we have a set of attacks and we have some models, let's look at what happens if we apply these things without any intelligence. And we'll hopefully look at why a plan is important. So this fuzz request it's super fuzzed, definitely, but it's not going to be useful. And why isn't it going to be useful? Because it's never in a million years going to get past our web server. And I'm not saying never fuzz your web server, but if you're trying to test your actual application and your code in your application, it's not going to be super useful. And why is that? So if we look at our method, right? Our method is invalid. And even if we got past our method, our host name is invalid. And even if we got past the host name, a bunch of our headers are also invalid. So right, we don't have a cookie header. So if we're trying to be interested in something that's in the cookie header, it's never going to get anywhere. And right, if we're interested in working on a specific path of our web service and we've completely fuzzed the path, then we're not even going to get there. And so what I'm saying is you need to be very deliberate and careful about what you're fuzzing in order, especially if you're doing black box fuzzing, because the system isn't going to be able to adjust itself to get to the areas that are interesting. You're going to have to provide that intelligence for it to find what is interesting to you, because it's going to vary from run to run, from team to team, from person to person. On the same time, if you fuzz too many things, it's going to be a wasted effort, right? Because you're not going to explore any interesting paths. You're going to have a hard time finding a repo of what exactly caused the problem. And it's going to be very much more difficult to make your data fit into a model that the system will accept. On the other side, if you fuzz not enough things, you're going to be wasting time, right? If you have only 1/5 of your requests fuzzed in a way that's applicable, or if you're only ever fuzzing the Q equals in your query parameter in your query line and nothing else, it's going to take you an awful long time to find something interesting, or you may have excluded areas that you didn't think of at the time that might still be valid for testing. So what we need to do is to make a plan. And this is pseudo XML, I guess it's XML-ish. But you need to make a plan to figure out what you care about. So if you never care about fuzzing your HTTP method because your web service only ever accepts a GET, and you're confident that that part has already been tested, then you probably should be testing your method very little, maybe 5% if you're not confident it's been covered, maybe 0% if you're like, nah, we got this. I don't care. I don't care about the method in my HTTP in my HTTP request. You should figure out what attack sets are valuable to you, right? Depending on your application. So if you're 100% JSON and you don't have XML anywhere in your system, you don't have any code to parse XML, it might not be super useful to you to have a whole bunch of XML-based attacks. If you never, ever use the cookie header, it might not be super useful to you to fuzz the cookie header. On the flip side, if your application 100% requires authorization every time and you're going to throw away every request without authorization, then you may not want to fuzz your authorization header too often. You may want to fuzz it a little bit to ensure that you've got coverage on the parsing of your authorization header, but realistically, if you're going to throw away 100% of traffic, if it doesn't have a valid auth header, then you're just going to throw away 100% of your traffic. And again, you're never going to explore any of the interesting branches in your application. So let's go back and look at our HTTP request again. So this one is a very effective fuzzing. Please use your imagination. Imagine there's like 50 times more A's in that query line, because that's not very interesting. Right, we've inserted some parse characters. There's a %20 in there. And we have intelligently fuzzed the cookie header such that if you go and look down through it, you'll see in this specific MUID cookie, we're injecting to see if we get an alert box popped up. That's interesting, especially if you know your application and you know, yeah, that's a user ID. We use it all over the place. Sometimes we echo it on the page, or sometimes we use it in a lot of our JavaScript code. You're likely to find something this way, or else to ensure that you haven't found something this way, right? This is interesting. And so what we've done is go from that, terrible HTTP request it's not gonna find anything. Nothing useful is gonna come here. It's gonna get thrown away. And we've instead started exploring the actually interesting bounds of our application. Here's another example of an also good HTTP request. You can see here that we didn't touch actually any parts of, we didn't touch the method, we didn't touch our authorization, we didn't touch any of those pieces. But what we've gone is intelligently said, this is a post body, and more specifically, this post body is JSON. JSON has a format. Let's respect that format. And it's gone and found that, our timestamp is a number. Let's put in a different number, a bigger number, and see what happens. Likewise, you can see down in the customer ID field that we've fuzzed within the bounds of valid JSON again. Right? We fuzzed inside the two quotes, and it's been smart enough to know, we need escape back, we need escape single quotes, because all of our JSON has double quotes. And so this is totally perfectly valid, valid HTTP request, valid body, but it may make something very interesting happen. And so this is what happens when you apply a plan. You go from randomized chaos that maybe 1 in a million will turn up something interesting to still randomized chaos, but something where maybe 1 in 10. And so if you can imagine that you're doing, say, 10, 20, 30 requests per second when you're testing your service, 1 in 10 is going to turn up an issue very quickly. And 1 in a million might be one of those sporadic crashing issues that is hard to debug, and everyone's like, it's low priority, we never see it. And it can be the difference between getting a very serious vulnerability identified and fixed and having one just live for years, forever, because nobody views it as very high priority. So let's talk about how we found something, maybe change tracks a little. So in some cases, it's very, very easy to know you found something. In some cases, it can be a little harder. But you're going to want to use harness your powers of observability, just like you would with any other production issue or investigating any other type of bug. And the most important thing is going to be understanding what normal looks like for your application, so that you can spot if something is abnormal. When I was doing fuzzing, I found it always very useful to compare the baseline of, say, a production environment or an environment that wasn't under fuzz traffic against one that was, especially if one had forked traffic and then one had fuzz traffic, because then that made it very clear that these were net new or something specifically driven out by fuzzing. So if you start looking at your counters, right, not just your set of exceptions or crash jumps, which of course are an easy place to go, But go look at your memory. Are you leaking memory? Is your memory allocation, is it running slow and steady like this, or are you constantly constantly trending up to the sky? The other thing you may want to take advantage of is side effects, especially if you're looking for SQL vulnerabilities or XSS or CSRF or code execution or something. You may be able to find it with metrics, but it's going to be a lot easier if you have a side effect. For example, popping up an alert box may not work if you're running a disjoint headless task, but if you have, instead of popping an alert box, you do, make your JavaScript increment a counter. Right, if you set a public counter up on your test site, you'll make your JavaScript increment a counter. You can check if that counter's been incremented, and then say, oh, I've got something. Same thing, right? If you've got your test SQL table looked up, and you've got a function that will just write something to your table, then you found something. Finding things that are more complicated than crash dumps is difficult. It's a little bit of an art. It usually requires experience in knowing what your application does and what it can do. You can also use the concept of an oracle. And an oracle will help you take those judgment calls that you might make, personally as a single person, and scale that out to make automated judgment calls. So it can say, I know that if my error rate on my fuzz bed goes over this amount, I need to fire an alert. Or here's my threshold for memory, and if I go above this memory, this set of allocated bytes, I need to fire an alert. So an oracle can look at what's happening in your environment, whether that's from a simple alert threshold for your alerting system, whether that's a separate application you run periodically to check, to call a bunch of, maybe it calls a bunch of databases and checks to see what's going on in there, check to see queries for specific data sets. The oracle can help you take some of the load off of investigating and at least take the low-hanging fruit off, so that you can spend time looking for the more interesting or the more esoteric things. So let's talk about what you can actually find. So you can find crashes, of course, especially if you're in an unmanaged system. We used to find C++ crash dumps all day and all night. It was really easy. If you're in a managed system, we generally, we had metrics on our top level exception counts. So we could find how many exceptions had been thrown, what the exception type was, etc. Those are very common. Those are easy. Oh no, we've got, all of a sudden we've caught 100 exceptions today under fuzz traffic under the new change, and we didn't catch any yesterday. Somebody probably introduced something bad. Oh no, the service is cratering, we can't bring it back up. Somebody probably introduced something bad. As I mentioned before, you can find memory leaks, you can find thread contamination, you can find places, missing a null terminator on your string. You can find places where you're allocating very messily and not deallocating. All those things that would be very difficult to find with traffic that seems sane, right? Because the biggest advantage of fuzzing, and the reason I tend to go to it as part test tool and part security tool, is our human brains are limited by our human imaginations. If you ask me to sit down and look at a web service and say, go test that, I'll probably come up with 20 or 30 interesting test cases. If I'm really, really experienced and comfortable, maybe I'll come up with 50 or 100. But they're going to start getting repetitive because there's limits to our human imagination in a given point in time. When you start rolling in like teed traffic, forked traffic, then it gets a little more interesting, right? Because then you have the collective imaginations of all your customers and the people that you're serving. And those are great too, but again, they're bounded by human imagination. When you start programmatically applying combinations, meanwhile, via a fuzzer, you are no longer bounded by those limitations, and you will get patterns that you never would have thought to do together because your brain instinctively rejected, oh, that's unreasonable, that won't work, whatever. And so that's how you can end up with a lot of things found that you never would have found otherwise. And of course, you can find a lot of exploits, especially depending on what exploits you've rolled in. So I got some requests for some examples, and I have good news for you. We're gonna play with some examples now. So everything that I'm showing you here today is available on the public GitHub repo. It's just open source license. It's no big deal. It is in .NET Core. I do not promise you that it is a production ready system, but it is certainly a fun proof of concept. You're welcome, of course, to clone it, modify it, make issues, make a pull request, et cetera, et cetera, et cetera. Standard open source and disclaimers apply. So don't mind me while I pretend that I can see this. So here's some code. The code lives here. It is dependent on FuzzDB. We can look at some of these vulnerabilities in a few minutes. But basically what it does is it wraps both FuzzDB attacks with a couple of other, the ability to have custom attacks, and then does some cleverness to apply either generational or insertion manipulations, apply that with the combination of a model and a strategy to do something really interesting. So let's take a look. We're going to hit some random website on the internet. No big deal. And so I've asked it to generate a couple of HTTP requests. They should look pretty familiar. A couple of interesting things to note. A .NET thing is that it's breaking up the accept encoding header, which is comma separated into, it's pretending that they're 3, they're not. Same thing with accept language. All the accept headers do that. So just keep that in mind, that if they seem to be fuzzed 3 times, it's not, it's a display issue because of .NET. So again, here's a bunch of requests. There's 5 of them. They all look exactly the same. And now we're going to make them very interesting. They became interesting. Oh, look at all those A's. So here, let's take a look at this. So you'll see none of them are fuzzed outrageously. In this case, we've got 2 attacks applied here in the query line. We fuzzed the path. You can see we've got an insertion manipulation. We've inserted a whole bunch of things into the path. Likewise, we've inserted similar things into the middle of the query line. But you see it didn't break the format of the query line. Here we've got the query line is fine, the path is fine, but we have gone and put so many A's inside the cookie. And not just inside the cookie. No, it's the accept header. We've replaced the name of the content type header with many, many, many A's. But that's all we did. Here's another one, and oh man, we put exciting things just in the middle of our query parameters. The format's still valid. Here we did a different attack, same concept. And here it looks like we've got some XSS injection going on. Again, in the query line. So we can send these requests, see what happens. Pretty interesting, they were all accepted, except one that was not found, which is not unexpected because we fuzzed the path. Everything else was accepted. That's interesting. A couple things to note here is if you're doing automated fuzzing, you need to make sure that you have predictability. So here we use a random seed so that we can always reproduce whatever insanity it was that we generated from run to run to run. And if I change this random seed, I don't know what's going to happen here. Something else will happen. So here's those same looking requests. Look at all those A's. That's great. There's so many. Here we fuzz them again. This one doesn't look super fuzzed. I don't see what happened to it. Could have been nothing. Could have been one thing that I'm having a hard time picking out. Here we've got some more XSS. Here we did something really bad to the cache control header. That'll be interesting. I'm really interested to see what the server does with that. Anyways, you can see, see if we can run some Perl. Sure, why not? So we execute these again. Come on. Our A's generated a bad request. That's interesting. We got a 500 level error this time from sending a whole bunch of data. The other ones again were all accepted. And I'm not going to send a lot more of these because I'm going to get flagged as a crazy bot. But you can see interesting things happen here. And so the next thing I would do, right, is I would go and check my observability, go and look and see, do all my metrics look normal? Do I have any side effects that I've triggered? Do I have any crashes? That 500 error especially could have generated a crash. I'm pretty sure it didn't because I know the service that I'm testing, but could have generated a crash. Anytime that you get a 5xx is suspicious. And so there's a lot of interesting things that could have happened. And this was just 10 requests. So imagine that you're generating 10 requests like these every second and you're running for an hour. Imagine you're generating 50 requests like these and you're running for an hour. Even an experienced security tester isn't going to come up with all these possible combinations that your fuzzer can automatically handle for you. There we go. And so that's why this is important. So here we've got, you can see we've got a model, we've got a strategy. I'm just using the defaults that are included. We could change the probability of fuzzing the query parameter. If I change this to 0%, God willing, I didn't write a terrible bug, we should see no query parameters get fuzzed. Yeah, so this one didn't get fuzzed, this one didn't get fuzzed. Other interesting things happened instead. Look at all these A's. Just skip right past them. You see, in no point, because my model, and I said to my model, I don't care about query parameter. I don't care about any query parameters. I don't care about the whole query line. Just ignore it. Test the things that actually matter to me. And it said, okay. And again, we triggered another bad request, probably the same one we triggered earlier with all those A's in the header. But by having full control this way, you can adjust to the scenarios that matter to you at any given point in time. If I really wanted to fuzz today, I wanted to really explore what my web server was doing. I could make it go a whole ham on web server things. If I wanted to say, I don't care, I know that my web server rejects bad methods, I don't care. Turn it off. Fuzz only the things that matter to you. Fuzz them for a long time, fuzz them at scale. And see the difference. So the point here is that you can fuzz what is important to you and ignore or or have it be a knock-on effect of things that are not important to you. You're generating so much garbage-looking traffic so fast that it doesn't really matter. If you're all curious, we can look at some of the actual attacks that it's being sent. So here's some of those hex values we saw with stuffing in there. Let's see, something interesting. Some NoSQL ejection attacks into Mongo. So these are all, this is from FuzzDB. I didn't invent these, but these are all attacks that have been used to exploit an actual vulnerability. So they are real. Right, some path traversal with bizarre encodings. I'm sure you saw at least a few of these come by in our example. Some exciting SQL injections. A lot of XSS. You kind of get the idea, I hope. So yeah, a couple other resources for you. I've got some references and further reading. If you really want to go deep, I recommend using fuzzingbook.org as a way to guide yourself through it. It uses Python. It helps you craft your own in-depth fuzzing runs. A lot of their concepts, they may use slightly different terminology than I do, but they have a lot of the concepts are very similar. AFL is great if it works for your use cases. If you can just use AFL, then you should absolutely 100% just use AFL. If you can't, because it doesn't work for your scenario as it does, because there's a lot of places where it won't, then you might want to use something else, like the service that I built here. FuzzDB, I've got a link to the FuzzDB project, which I love very much, and I hope very, very, very much that they continue to maintain it. Microsoft has recently published an open source HTTP fuzzing tool called Wrestler. I haven't personally used it yet, but I have a couple of colleagues who have, who are really excited about the possibilities. And of course, Kali Linux has a bunch of various fuzzing tools built in if you just want to grab something off the shelf. Otherwise, I had a link up in the beginning. I'll post it later on in the channel to my website, which has slides and examples. If you go to my GitHub repo, it also links to slides and examples. Queen of Code /.NET model fuzzing. Get a little more legible. This has links to the slides as well, and to FuzzDB and to Fuzzing Book, etc. Usually the easiest place to get all that is from the GitHub repo, though, which I will also post in the Discord. That said, thank you all for bearing with me today on this very windy Saturday morning. And I would love to answer questions or show off some more fuzzing runs. I get a lot of joy out of just watching the fuzzing runs and seeing what it does. It's very entertaining.
Can I kick off with like a really light question?
Yeah.
Do you always laugh maniacally when you see the A's? Because that was
I do actually. I actually do, because it gives me so much joy to see them, because I've found so many ridiculous bugs. That was how I spent, I once spent a solid 8 or 9 hours trying to drive out that cross-process thread contamination issue. And what we did with it was so many A's, because then it was how we could finally trigger enough. We could rewrite enough of the memory buffer that we could see it show up in weird places. It is literally my favorite way of driving out some of those vulnerabilities.
As other people maybe formulate some questions to throw into the chat or unmute themselves and say them out loud, I do have one. So in terms of a fuzzing plan, how do you suggest, how do you approach, what are your thoughts on stuff that's not yours but really important to your security? AKA, I think it might hide from my question. Third-party components, open source things, stuff you would consider part of your supply chain that's important to make your service work or deliver your product.
Yeah, so there's really two types of fuzzing runs. One is a steady state sort of baseline maintaining one, and the other is a fishing expedition looking for something specific. So if we're talking about your steady state fuzzing run, you should keep all of the, so if you look at my plan here, my example plan, oh my gosh, I have so many things open. Definition, the default strategy here has some things at a high probability and some things at a very low probability. So those things that are not your responsibility that are important, rather than setting the probability to 0, set it small so that you don't never hit it, but you spend a lot more time on the things you care about. Realistically speaking, if 1 out of 1,000 of my requests is attempting to, to fuzz something that's low level in my HTTP service, and I'm running, again, I'm running 60 requests per second, it's not going to take me very long to find that issue. But I will be much more likely to find the issues I actually care about. So it's a matter of balancing the time and how long you're going to do the run. If you're doing it 24/7, you don't need a super high probability in order to drive that stuff out. Whereas if you're on a fishing expedition for something specific in your application, you only want to run it for 5 minutes and you're limited in the traffic you can send, you may want to say, I'll get to that other stuff later. I really just want to dig at the specific class of issues or the specific chunk of the code. So it's about min-maxing your time specifically and your human effort, because that part's the expensive part. Machine time is really cheap.
I like that, and too, the way you answered it really changed my perspective on it too. So I appreciate that.
Yeah, no problem.
Anyone else have any questions?
Any other questions? I'm trying to see if I missed anything.
I threw up 2 of them, but that was a pretty good answer. That first one, that was pretty good. My other question was more. We dig into that, what the idea of an oracle is a little bit. Where does it come from? How does it get there? Like, just expand on that just for a minute, if you don't mind. It was a really cool concept.
Yeah, and it's a concept we could talk about for a really long time. It's almost writing a good oracle is almost an hour talk all by itself. So the very simplest oracles most of us are probably familiar with are your alerts, right? The things that trigger your, that call you on pager duty. If we're talking about Datadog terminology, right? You got your graph and you've got your threshold, and when your data point goes above the threshold, it triggers an alert. That's the simplest possible oracle. It says if value greater than X, something bad happened. And that's the kind of simple oracle you can get out of your observability tools. But if you're willing to write some code or write some scripts, you can get much more complex things. You can say things like, if my memory threshold exceeds this value and my traffic count is like this and my exception counts are like that, then something bad happened. Is a slightly more complex one. And then you can get to oracles that are very application specific. You can say things like, if I'm writing to this if I go and scan this table for things that were written to it in the last 5 minutes, and I see that I'm getting something that looks like X, then I know something bad happened because I wrote my JavaScript to write to this table if I triggered an XSS. And so your oracles can get very, very specific to your application. Basically, think of anything you would do to check if something bad happened. If you can do it programmatically, it's an oracle.
Yeah, hearing you say that out loud makes it sound a little better. Like even in my question, all right, it makes me understand more. Like even my question was more about where do I get one? And that makes no sense at all now that I hear you explain it. It's an oracle for your thing. So
it's an oracle for your thing.
Yeah. It's not like you can build on something, or it's more of a way you track those things.
Exactly. And you can get some of them off the shelf, right? Like most observability tools will come with some metrics basically out of the board. Oh no, your CPU's been pegged at 100% for 5 minutes. Alert. But they're probably not going to be all that useful to you. They're better than nothing, but they're not exactly highly tuned and customized to what you expect your steady state to be, and what does a deviation from that look like, and when is it bad to deviate.
All right. If anyone else has questions, you could always go to the Discord. You can talk in the lobby. There's a text chat in the lobby, and there's also a voice chat called Talks Q&A, where you can continue the Talks Q&A. But yeah, I mean, I just 1,000 times thank you for
no problem. My pleasure.
and sharing this information. I think anyone who hears that is definitely smarter for it. I don't know how else to say it. I'm just trying to find the biggest compliment I can give. It was wonderful. Thank you.
Glad to be here.
All right. Our host, Aiden, I guess you can end the recording, please.
All right.